The biggest pressure washer killer doesn't happen while you're cleaning. Ironically, it happens while you're doing absolutely nothing. Every year, thousands of perfectly good pumps destroy themselves because of habits that almost every owner thinks are normal. And unlike an action movie hero, your pressure washer doesn't get a dramatic comeback in the sequel. Once the pump destroys itself, your wallet becomes the next casualty. So let's talk about the 5 mistakes that quietly kill pressure washers every single year. Here's something that catches a lot of people off guard. Your pressure washer is one of the very few machines that can damage itself. While appearing to do absolutely nothing, you're halfway through cleaning the driveway when your phone rings. You let go of the trigger, leave the machine running to chat for a minute. Or maybe admire just how disgustingly dirty the concrete used to be. Then come back and start spraying again. After all, the engine's still humming along happily, and nothing is smoking or sound broken. So what's the problem? The problem is that the moment you release the trigger, your pressure washer doesn't actually stop working. Inside the pump is an unloader valve, and its job is to protect the pump from the enormous pressure that builds up when the spray gun suddenly closes. Instead of allowing pressure to spike high enough to burst a hose, the unloader opens and redirects the pressurized water back through the pump in what's known as bypass mode. It's an ingenious safety feature. The trouble is, people mistake it for an operating mode when it's more like the automotive equivalent of idling your car at the red line. The system can tolerate it briefly, but it was never designed to stay there. Here's why. When you're actively spraying, fresh water is constantly entering the pump. That incoming water does more than carry dirt away. It also removes heat from the pump manifold, the ceramic plungers, and the high-pressure seals every single second. The instant you stop spraying, that cooling process stops too. Now the same small pocket of water is being forced around the pump again and again. Those plungers are still cycling hundreds of times every minute, compressing the same trapped water with nowhere for the heat to escape. Before long, the water temperature starts climbing surprisingly fast. On commercial machines fitted with a thermal relief valve, the system will eventually dump that overheated water onto the ground before it becomes destructive. Many homeowner machines don't have that luxury, so the heat keeps building. Rubber O-rings begin losing their elasticity. High-pressure seals start hardening, and plastic valve cages can soften. Even the lubricating film protecting moving components begins breaking down. You won't notice any of this while it's happening, but the next time you squeeze the trigger, the pump may suddenly struggle to reach full pressure. Or worse, you'll notice water dripping from underneath the machine, where it never leaked before. And that's usually the first clue that the damage is already done. The ironic part is that none of it happened while you were cleaning. It happened while you weren't. That's why professional contractors develop a habit that homeowners often don't. If they know they're stepping away for more than about a minute, they shut the machine down completely. It takes one extra pull of the trigger or one press of a switch to start again, but that's a lot cheaper than replacing an entire pump assembly. Because despite looking like the toughest part of the machine, the high-pressure pump has one weakness. It absolutely hates sitting still, and if overheating is one way to destroy a perfectly healthy pump, the next mistake kills pressure washers before they even have a chance to overheat. It starts the moment people buy a machine that's completely wrong for the job they expect it to do. Most people shop for pressure washers by looking at the biggest number on the box. If one says £3,200 per square inch, and the other says £2,000 per square inch, the decision seems obvious. A bigger number means bigger cleaning power, except that's only part of the story, because choosing a pressure washer based on PSI alone is a bit like trying to force a square peg into a round hole. The machine isn't bad. It's simply being asked to do something it was never designed to do. Take a typical residential electric pressure washer. They're brilliant for washing cars, bicycles, patios, decking, and the occasional driveway. They're lightweight, quiet, easy to maintain, and, for most homeowners, exactly the right tool. The trouble starts when someone expects that same machine to clean a warehouse floor, an apartment complex, or an industrial parking lot for 6 hours straight. That's the pressure washer equivalent of asking a golf cart to tow a fully loaded semi-truck. Technically, they're both vehicles realistically, however, only one is built for that job. It reminds me of that classic I Love Lucy episode, where Lucy and Ethel are wrapping chocolates on a conveyor belt. Everything starts off perfectly manageable. Then the conveyor speeds up. Suddenly chocolates are piling up faster than they can keep up. So they start stuffing them into their hats, their pockets, and even their mouths just to stop the chaos. Your pressure washer goes through something remarkably similar. Unlike Lucy, though, it can't hide the extra workload under its hat. Inside most residential electric pressure washers is either a universal motor or a quieter induction motor, depending on the model. That motor usually drives an axial cam pump, which is compact, affordable, and more than capable of handling the sort of weekend jobs it was designed for. What it isn't designed for is running continuously like a commercial machine. That's where the duty cycle comes in. Every pressure washer is engineered with an expected workload, while residential machines are intended for shorter cleaning sessions, with occasional cooling breaks. Commercial units, on the other hand, are built for endurance. Many use petrol or diesel engines from manufacturers like Honda, Kohler, or Briggs and Stratton, coupled to heavy-duty triplex plunger pumps with ceramic plungers and rebuildable packings that can withstand hours of continuous operation. The pressure washer might seem fine at first, but the pump keeps trying to pull in more water than it's actually receiving. Inside the pump manifold, the plungers create a low-pressure area every time they retract, drawing fresh water through the inlet check valves. When the water supply can't keep up, those low-pressure zones become so severe that the liquid briefly flashes into vapor, forming countless microscopic bubbles. This is a phenomenon called cavitation. Surprisingly, those bubbles aren't what cause the damage. It's what happens when they disappear. As the plungers reverse direction, pressure inside the pump rises almost instantly. The vapor bubbles collapse with incredible force, releasing tiny shockwaves against the surrounding metal. One collapsing bubble is harmless, but millions of them collapsing every minute is another story entirely. Over time, those microscopic impacts begin pitting the pump manifold, eroding the check valves, scarring the surfaces of the plungers, and accelerating wear on the high-pressure seals. It's one of the few failures where water, the very thing that's supposed to protect the pump, starts acting like a tiny jackhammer from the inside, and your pressure washer usually tries to warn you before it gets that far. Instead of its normal smooth hum, the pump develops a harsh rattling or knocking sound, almost like someone has dropped a handful of nuts and bolts into a kitchen blender. The spray pattern becomes uneven, the nozzle spits and surges, and the pressure seems to have a mind of its own. Most people immediately blame the nozzle or start shopping for a replacement pump, when the real problem might be nothing more than a water supply that's struggling to keep up. Fortunately, checking that is surprisingly easy. So before you start cleaning, try what's known as the bucket test. Place your garden hose into a standard 5-gallon bucket, turn the tap on fully, and time how long it takes to fill. If it takes more than about 2 minutes, your water supply probably isn't delivering enough flow for a heavy-duty pressure washer. While you're at it, straighten out any kinks in the hose. Make sure the tap is fully open, and avoid sharing that water supply with sprinklers or other equipment while you're washing. Because here's the irony. People spend hundreds of dollars chasing more pressure when the real problem is that the pump simply isn't getting enough water to create it. And speaking of things quietly restricting water flow, the next mistake is hiding in plain sight. It's a tiny filter, no bigger than a bottle cap, that most owners don't even realize their pressure washer has, until it clogs. Every pressure washer has an inlet filter, usually a small plastic housing containing a fine stainless steel or nylon mesh screen, where the garden hose connects. Its job is to catch rust flakes from aging water pipes, grains of sand from well systems, and other debris before they reach the pump. Unlike the garden hose, the pump has extremely tight internal clearances, so even tiny particles can cause problems. Those tiny check-like valves, plungers, and high-pressure seals don't react well to dirt being blasted through them. The filter is the first line of defense. Ironically, that eventually becomes its own problem. Over time, rust particles, sand, mineral deposits, and even slimy algae begin collecting across that fine mesh. At first, you won't notice anything, but as more of the screen becomes blocked, water has a harder and harder time getting through. You experience the pump still trying to draw its normal volume of water, but the clogged inlet filter is acting like someone slowly closing a valve upstream. Before long, the pump begins starving for water all over again, and the symptoms look remarkably similar to cavitation. The spray starts surging and pressure rises and falls without warning. The machine may run perfectly for a few seconds before the water stream suddenly weakens into little more than a disappointing trickle. Because the restriction is before the pump, many people misdiagnose the problem completely. They replace spray tips or assume the motor is wearing out, when the only thing standing between them and full pressure is a filter that hasn't been cleaned in months. Thankfully, this is probably the cheapest repair in the entire video. Turn the machine off, disconnect the garden hose, and look directly inside the water inlet. On most models, you'll see the small inlet screen sitting just inside the fitting. Carefully remove it with a pair of needle nose pliers or a small pick. Rinse away any sand, rust, or debris under clean running water, then pop it back into place. The whole job usually takes less than a minute and costs nothing. And in many cases, restores full water flow immediately. Unfortunately, the final mistake isn't something you'll notice while you're washing. You'll discover it months later, when water starts pouring out of the pump housing, before you've even cleaned a single paving stone. This final mistake, however, doesn't happen while you're cleaning at all. It happens months later, after you've rolled the pressure washer into the garage, congratulated yourself on another spotless driveway, and forgotten that the pump is still holding water deep inside its pump manifold, discharge passages, and check valve chambers. That becomes a very expensive problem the moment temperatures drop below freezing. Water is one of the few substances that expands instead of contracts as it freezes, increasing in volume by roughly 9% as its molecules lock into a crystalline lattice. In an open container, that's harmless. Inside a sealed aluminium pump manifold, it's a completely different story. The pump housing is engineered to contain thousands of psi of moving water, but it's never designed to accommodate expanding solid ice. As the trapped water freezes, the expanding ice creates enormous hydraulic expansion stresses against the manifold walls, valve seats, and high-pressure galleries until the aluminum simply reaches its yield limit and fractures. The frustrating part is that the crack often isn't obvious. Sometimes it's nothing more than a hairline fracture running through the pump head. Other times the manifold splits wide open around a check valve bore or outlet port. Either way, the damage happens sometime in January. You just don't discover it until the first warm weekend of spring, when you reconnect the garden hose, squeeze the trigger, and watch water erupt from the side of the pump instead of through the spray nozzle. At that point, replacing an O-ring, tightening a fitting or wrapping the threads in PTFE tape won't accomplish much because the structural casting itself has failed. On many consumer pressure washers, replacing the entire pump assembly costs enough that people simply replace the whole machine. Fortunately, preventing freeze damage is almost embarrassingly simple. Before storing the unit for winter, disconnect the water supply and run the pump for around 10 seconds to purge as much residual water as possible. Better still, inject a can of pump saver or a dedicated pump antifreeze through the inlet fitting. It displaces any remaining water, leaves a protective film on the seals and check valves, and dramatically reduces the risk of corrosion and freeze damage during storage. 5 minutes of preparation in autumn can save you hundreds of dollars in spring, because despite their rugged appearance, pressure washers rarely lose the fight against dirt. More often, they lose the fight against a few ounces of forgotten water trapped exactly where it shouldn't be. If you found at least one mistake you've been making, hit subscribe, because the next expensive tool you save might be sitting in your garage right now.